Okay, number 2, particle A is moving along a straight line such that its displacement from a point P after t seconds is given by S of A is equal to 15 minus t minus 6t cubed times e to the negative 0.8 t between 0 and 25. This is shown in the following diagram. Find the initial displacement of particle A from point P. Initial displacement is going to be when time is equal to 0 of the original and that is going to be equal to 15. Okay, so that makes perfect sense, right? If this is P or the origin, the initial displacement from the origin is going to be 15 units. So we would say 15 units. Oh, it's in centimeters, sorry. So 15 centimeters right of the origin. 2b. Find the value of t when particle A first reaches point P. When it reaches point P is when it crosses the t axis, right? So we're going to find that first t intercept, and we're going to do that on the graph. So go ahead and graph it on your calculator, and then you can do just graph trace if you want, and that'll give you time equals 2.47. That's when the first x-intercept is. So we would look for first x. Oh, sorry, the axis is t. So first t intercept occurs when t is equal to 2.47 seconds. That's so thin. There we go. 2c. Find the value of t when particle A first changes direction. So a particle changes direction when v of t is equal to 0, or when the velocity is equal to 0. Since this is the graph of the position function, we want to find the spots where the derivative would be equal to 0. The slope of the tangent line would be equal to 0, and that's going to occur at minimums and maximums. So we want to find the first spot when it changes direction. That's going to be located at the first max or min. The first happens to be a minimum. So let's go ahead and find that on the calculator. Okay, so the first minimum is going to occur at time is equal to 4.08 seconds. Okay, sweet. Find the total distance traveled by particle A in the first 3 seconds. Total distance traveled, since we're allowed to use our calculator, we just have to think about the bounds. So first 3 seconds would go from 0 to 3, and then we know that the total distance traveled is going to be equal to the absolute value of v of t if you took the integral with respect to t. So we are going to just type that into our calculator, right? All right, so we don't want to actually calculate the derivative by hand, so what we're going to do is add it as a graph. So we would go in here and get derivative with respect to x of the first function that's stored in var. That's going to be f1 of x. Hit enter. We don't really care about what the graph of the derivative looks like, but we do want to use it in order to type in our integral. So you would just type in an integral as usual. Let me just show you how to do this, just in case you don't know. All right, so we have from 0 to 3, and then we put our absolute value bars here. You're going to go to the lobster, absolute value, and then this is the big time saver, right? You pick up the variable by going to F2 because that's where you graphed the derivative, and then now you don't even need to type it in. You don't even know what the derivative is. You just know that you're going to be using it, and you're saving yourself a bunch of time. So the total distance traveled is going to be 17.7 centimeters. Okay. 2e. Another particle B moves along the same line, starting at the same time as particle A. The velocity of particle B is given by, okay, so they give us the velocity here, 8 minus 2t, and that's on the same interval from 0 to 25. Given that particles A and B start at the same point, find the displacement function for particle B. Okay, so if they give us the velocity, we're going to need to integrate to get back to the displacement. So we're going to find the integral of the velocity that they gave us, right? So that's supposed to yield us the position function, S sub b. So let's go ahead and integrate that, okay? They gave us 8 minus 2t dt. To integrate that, we would get S sub b is equal to 8t minus t squared plus c. Don't forget that plus c. So what can we use to find that plus c? Well, it's along the same line with the same starting at the same time as particle A. So if it's along the same line and starting at the same time, when time was equal to 0, the initial position from the origin should have been 15 units. So we can use that information in order to find that missing pesky little c. All right, so now we would get 15 is equal to c. And now we have our fantastic little position function. Alrighty, sweet. Okie dokie. 2f. Hold on, let's highlight this. 2f. Find the other value of t when particles A and B meet. So particles A and B meet. That means we're going to try to find where S sub B is equal to S sub A, because we're trying to find where they meet, right? So we have S sub A is equal to S sub B. Since they say find the other value, it looks like we're probably going to get two answers, and then we're going to need to make a judgment call and see which one they're actually looking for. So let's go ahead and put in S sub A. That was 15 minus T minus 6T cubed e to the negative 0.8t, and let's set it equal to the position function that we just found above. Okay, obviously this is a algebraic nightmare, so let's go to our calculator. We don't need this derivative anymore, do we? Nope. Okay, so I'm going to delete it. Go away, go away. Okay. So we have the first thing. Oh, and now we're adding the second curve. Okay, so we have 8x minus x squared plus 15. Let's go ahead and find where they cross. Okay, so it looks like they cross right here. Oh, my email is just blowing up. Looks like they cross when time is equal to 9.3. So just write that you found it in your calculator. For the intersection, time is equal to 9.3.